All right, in this video, we're going to talk about complements. So let's talk about the complement of event A. Right, and notation-wise, you'll see this written as A with a little superscript C. Okay, I've also seen this written as A prime. And my least favorite way, but I do see it occasionally, it's an A with like a bar over it. Okay, so this is just different notations for complement. Okay, this guy's my favorite. I think that's pretty clear about what you're talking about. You have a little C there. We're talking about the complement. Okay, so what is this? This is the set of all elements in the sample space, right, S, that do not belong, do not belong in A, right? So if I were to draw this out using a Venn diagram, right, this is my sample space, and suppose this is A here, event A, then a complement would be everything except A. All the events except whatever A is. This is a complement. Right? So for example, okay, suppose A is, or actually, let me give our sample space. Suppose we're rolling a die, okay? So our sample space is 1, 2, 3, 4, 5, or 6, because we have a 6-sided die. And then A is that we roll an even die, so that means 2, 4, or 6. Then a complement will be that everything else, right? So not 2, 4, or 6, but everything else, which will leave me with 1, 3, or 5. Okay? All right. Another example, suppose our sample space is X such that, X is between 0 and 1, including 0 and 1. And then A is X such that X is more than 1/2, more than or equal to 1/2. Okay, and sometimes when you have problems like this, it's helpful to draw out draw out the number line and see what you have here. So our sample space is between 0 and 1, right, including both 0 and 1. This is my sample space in yellow. And then if I were to draw out A using blue, A goes from 1/2, including 1/2, all the way until 1, including 1. Okay, so then the complement would be everything else. So that'd be basically between 0 and until I get to 1/2, but I would not include 1/2 since 1/2 is part of A. Okay, so a complement would be X such that we are between 0, including 0, because that's part of our sample space, and then I would go all the way to 1/2, but I would not include 1/2 because that is definitely part of A. Okay. All right, a few important notes before I move on from sample space or from complements. Some important notes. Okay. First, if you have a complement, and then you take the complement of that, the complements kind of cancel each other. Okay. So if I think about this, here's A, right? A complement is everything that's not A, and everything that's not A is A, right? It's kind of like a double negative. They cancel each other. Also A, union, A complement. Remember, union means or. So A or A complement. So if we are part of A and A complement, so that's basically this purple area here, right, or the red area, then that's basically going to be our entire sample space. Okay. Number 3, the complement of the null set. Okay, so the null set is nothing. So the complement of nothing is everything. That's also the sample space. Okay, next, let's do A intersection, A complement. Okay, intersection means and, right? So let's see, what would this be? So the red is A complement, and the purple is A. So do any elements belong both to A complement and A? No, right? It's one or the other. So there's nothing. That's the empty set. Okay. And then lastly, the complement of the sample space. So the complement of the entire sample space would be nothing. So the opposite of nothing is, or the opposite of everything is nothing. The opposite of everything is nothing. Similarly, the opposite of nothing is everything.